My name is Joseph Moon and this is Lab 5, Choose Your Own Adventure. The purpose of this lab is to compare the observed and predicted motion of two objects in a collision. The system includes two glue sticks and then the earth is also included, meaning the surroundings is none. And the preview of the results is the observed and predicted x and y position data for stick 2, which was at rest initially, were more similar to each other than those of stick 1. And also kinetic energy and momentum were not conserved. Some models we will need to know include Newton's second law, conservation of momentum, energy principle, inelastic versus elastic collisions, and then point particle versus real systems. In an elastic collision, the change in kinetic energy is 0, so kinetic energy would be conserved, but in an inelastic collision, the change in kinetic energy is not 0, so energy is lost to the surroundings. In point particle, all external forces act on the center of mass, and kinetic rotational energy is not considered, while in a real or multi-particle system, the system is not a point, so works need to be calculated separately for each external force, and rotational kinetic energy will also be considered. Some relevant formulas include the velocity update formula, position update, change in kinetic energy, momentum, conservation of momentum, and then conservation of kinetic energy. For this experiment, before the collision, stick 1 has a non-zero momentum because a force was applied, and stick 2 is at rest, so it has 0 momentum. During the collision, some momentum and kinetic energy from stick 1 is transferred to stick 2, and after, both sticks have non-zero momentum. And this is the video of the collision. So this is the code for the predicted data graphs in GlowScript. The top box is the stick 1 trail 1, stick 2 trail 2, and the origin, which just sets up the graph. And then for plot x pos and plot y pos, this middle box is setting up the graphs with the titles and whatnot, and then the bottom is the stick 1, stick 2 mass and initial position and initial velocity. For this code, it's a while loop while t is less than 1.667 because this is before the collision occurs. Fnet 1 and 2 are set to 0, 0, 0, and then we have the velocity and position update formula in the middle box, and then the bottom is the change in position in the graphs as the while loop occurs. And then we have on the top the new velocities after the collision, and we have a while loop while t is less than 3.750, which is you're iterating for the same velocity and position update formulas, but until the video ends. So for stick 1, the x position versus y versus time and y position versus time for predicted and observed motion had a huge discrepancy in the data as opposed to stick 2 for the x position and y position. In stick 2, the data for predicted and observed was very similar to each other, and these can be explained by some sources of error, including inaccurate placement on the timestamp marker for sticks 1 and 2, other external forces such as friction that were not considered, and rounding the values during calculation and rounding the position data may have caused the accuracy to deviate. So, is kinetic energy conserved? And what does it mean? With this work that's shown here, you can see that the initial and final velocity or final kinetic energies are not the same, so kinetic energy after the collision is smaller, meaning the collision is inelastic. Some energy must have been converted into heat, sound, etc., and as stated before, friction and other external forces were not considered but would be present. Also, is momentum conserved? Momentum was not conserved, and as you can see in the work shown, the momentum final was smaller after the collision. And what if the glue stick initially at rest had a larger mass? What would happen to the value of the final velocity of that stick? The final velocity would be smaller because more momentum will be required to achieve the same velocity as in the original system where the masses are equal.